Look up at the night sky. What do you see? A canvas of diamonds, scattered across an infinite void. For millennia, humanity has gazed upon this spectacle, wondering what lies beyond. Where do we fit into this grand cosmic design? We are here, on a pale blue dot, orbiting an ordinary star, nestled within one of hundreds of billions of galaxies, each a colossal island of stars, gas, and dust. But these islands are not static. We are adrift on an ocean that is perpetually expanding. This is the story of our universe, its birth, its evolution, and the mind-bending journey of its expansion, a journey that began with a bang. A galaxy is far more than just a cluster of stars. It is a gravitationally bound system of stars, stellar remnants, interstellar gas, dust, and an enigmatic component we call dark matter. Imagine an entire city of stars, countless suns, each with its own potential planets, all orbiting a common center. That is a galaxy. Galaxies come in a breathtaking array of shapes and sizes. The most recognizable are the elegant spiral galaxies, characterized by their flat, rotating disks and prominent spiral arms, much like our own Milky Way. Then there are the majestic elliptical galaxies, vast, spherical or egg-shaped collections of older stars, often appearing as cosmic footballs. And finally the irregular galaxies, chaotic, and often smaller, born from gravitational interactions or collisions, lacking a defined structure. Our home, the Milky Way, is a barred spiral galaxy, a colossal structure spanning over 100,000 light years, housing an estimated 100 to 400 billion stars. Every star you see with the naked eye is a part of it. But beyond our galactic neighborhood lies an unimaginable expanse, filled with billions and billions of other galaxies, each a universe unto itself. For centuries, we believed these distant nebulae were just clouds within our own galaxy, until a revolutionary discovery changed everything. For much of history, the universe was considered static, unchanging, an eternal and immutable backdrop to our existence. Even Albert Einstein, in his groundbreaking theory of general relativity, initially introduced a cosmological constant to force a static universe into his equations, something he would later call his biggest blunder. The paradigm shift began in the 1920s, largely thanks to the meticulous work of astronomer Edwin Hubble. Using the powerful Hooker telescope at Mount Wilson Observatory, Hubble observed distant nebulae and identified individual stars within them, proving they were not gas clouds in our galaxy, but separate, distant galaxies. More profoundly, he observed that light from these distant galaxies was shifted towards the red end of the spectrum, a phenomenon known as redshift. This redshift indicated that these galaxies were moving away from us. And critically, the farther away a galaxy was, the faster it appeared to be receding. This groundbreaking observation, now known as Hubble's law, provided the first concrete evidence that the universe was not static, but was, in fact, expanding. To understand this expansion, imagine a balloon with dots drawn on its surface. As you inflate the balloon, the dots move farther apart from each other, not because they are moving through the surface, but because the surface itself is stretching. Similarly, in our universe, it's not that galaxies are flying through a static space, it's that the fabric of space-time itself is expanding, carrying the galaxies along with it. Every point in the universe sees every other point moving away, an elegant and profound consequence of the universe's dynamic nature. If the universe is expanding, then logically, in the past it must have been smaller, denser, and hotter. This simple extrapolation is the cornerstone of the Big Bang Theory, our most widely accepted cosmological model describing the origin and evolution of the universe. It's crucial to understand that the Big Bang was not an explosion in space, but an expansion of space itself. According to the Big Bang model, approximately 13.8 billion years ago, the entire observable universe was compressed into an incredibly hot, dense state often described as a singularity. From this unimaginably compact state, space-time began to expand and cool at an extraordinary rate. In the first fractions of a second, an event called cosmic inflation stretched the universe exponentially. One of the most compelling pieces of evidence for the Big Bang is the cosmic microwave background CMB radiation discovered accidentally in 1964. The CMB is the faint afterglow of the Big Bang itself, light emitted when the universe was only about 380,000 years old, cool enough for atoms to form and light to travel freely. This ancient light, now stretched into microwaves by the universe's expansio, N, perfectly matches the predictions of the Big Bang theory. Further support comes from the abundance of light elements in the universe. The Big Bang model occur 8ly predicts the observed cosmic ratios of hydrogen, helium, and lithium. These elements were forged in the first few minutes after the Big Bang, during a period of intense heat and density known as Big Bang nucleosynthesis. The universe is a vast chemical fingerprint of its own fiery birth. As the universe continued to expand and cool, gravity began its work, pulling together vast clouds of hydrogen and helium gas to form the first stars. These stars, in turn, aggregated into the first Galaxies, eventually leading to the cosmic landscape we observe today, teeming with galactic islands, all still moving apart, carrying the echoes of their origin. The story of the universe's expansion doesn't end with its birth. It continues to unfold, and its ultimate fate remains one of science's most profound mysteries. Our understanding of this future hinges critically on two enigmatic components that dominate the cosmos: dark matter and dark energy. Dark matter, invisible and undetectable by light, makes up about 27% of the universe's mass energy content. Its gravitational pull helps hold galaxies together. But even more perplexing is dark energy, which constitutes about 68% of the universe. Far from slowing down the expansion, observations from distant supernovae revealed in the late 1990s that dark energy is actually accelerating the expansion of the universe. This accelerated expansion presents several possible scenarios for the universe's ultimate fate. The most likely, given current data, is the Big Freeze, or heat death. In this scenario, the universe continues to expand, cooling endlessly until stars burn out, black holes evaporate, and all matter disperses into a cold, empty void. Less likely, but still theoretically possible, are the Big Rip, where dark energy becomes so dominant it tears apart galaxies, stars, and even atoms, or the Big Crunch, where the expansion eventually reverses, causing the universe to collapse back into a hot, dense star. Though current evidence strongly argues against this. These are not just abstract scientific conjectures, they are profound questions about our cosmic destiny. The universe is a grand experiment, and we are living within it, tiny observers attempting to decipher its rules and predict its ultimate conclusion. From the breathtaking spirals of distant galaxies to the echoes of the Big Bang, from the accelerating expansion driven by mysterious dark energy to the potential fates that await us, the journey of understanding our universe is one of humanity's greatest adventures. It is a story of meticulous observation, groundbreaking theories, and an insatiable curiosity that pushes the boundaries of our knowledge. We are a product of this universe, made of stardust, connected to its very origins. Each new discovery reminds us of our small place, yet also of our extraordinary capacity to comprehend the vastness around us. The universe continues to unfold its secrets, inviting us to look deeper, question further, and marvel at the incredible cosmos we call home. The expansion continues, and so too does our quest for knowledge. What wonders will we uncover next? Thank you for watching our video. Don't forget to like and subscribe. We value your thoughts greatly. Let us know in the comments.